Well, pre-calculus classes, good morning, good afternoon, or good evening. As always, we are going to now finish up our final unit of the year, which is Chapter 6, and we're going to talk about some final trigonometric concepts with it. Now, I know earlier in the year we did some problems. If you remember, there was one I know where we talked about the hunter shooting at the mountain lion, the elk, and one of the issues that did come up with it was we had to construct some right triangles. I know on that same worksheet there was even a problem where someone was looking up at a friend at the top of a building and then also looking down at the bottom of the building, and once again, using angle of depression, angle of elevation, you did again have to construct some right triangles as you did that. Well, now we are going to go over some options involving ways to solve what are called oblique or non-right triangles. One of those two options is what is called the law of sines. Now, the law of sines looks like this, where if you take the sine of angle A divided by the length of side A, it will equal the sine of angle B over the length of side B, or you can certainly use the third angle, sine of angle C over the length of side C. Now, as you solve these problems, you will only use two of the three angles and two of the three sides at one time. You can either use angles A and B, you can use angles B and C, or you can use angles A and C. You will not ever have all three fractions in a proportion as you work. So, certainly as you go, you will see how these work, and when you'll use different sides and different angles. So, to get started, first off, our directions here. For example, 1, solve the triangle if A is 40 degrees, B is 60 degrees, and side A is 4. Well, when you see the directions solve the triangle, what that means is to find all missing sides and angles. So, if we have A is 40 degrees, B is 60, side A is 4, one of the things I always like to do is, as I solve these, just sketch a triangle here. It doesn't have to be exact, but something, at least that reasonably fits what you have. So, here's my 60-degree angle, here's my 40-degree angle, so that's A, that's B, and then side A is opposite angle A. So I'm going to put that here. One of the other things too, anytime you see a capital letter, that signifies an angle. A lowercase letter signifies a side length. Alright, so from here there are three things we need to find. We do need to find side B, side C, and of course the easiest thing that we can go ahead and start with is angle C. Well, to find angle C, we know all three sides, all three angles in a triangle add up to 180. So, angle C will equal 180 minus 60 and 40. So, angle C is 80 degrees. Alright, so again, and we'll kind of talk about some things with this as we go. Now, to get started, we have 40 degrees and a length of 4. So I'm going to start my first proportion as the sine of 40 over 4. And certainly if you put the side lengths on top of the angles, as long as you stay consistent all the way through, that is perfectly fine. Equals the, and I'm going to just start with 60 degrees, the sine of 60 over B. Now, from here, what I always like to say is we are going to cross multiply to solve. So, B times the sine of 40 degrees equals 4 times the sine of 60 degrees, and then divide by the sine of 40 degrees. Now, before you do anything with this, first thing I would recommend, go in, double check your calculator mode. Make sure it is in degrees, as that is what we're going to be working with for the majority of Chapter 6. Now, from there, I'm going to take 4 times the sine of 60, and I'm just going to enter this all in at once. Close your parentheses and divide by the sine of 40 degrees. And when you do that, you end up with an answer of around 5.4. Now, one of the other things you can always look at is, as you go, do your answers fit? Well, B is across from an angle that's larger than A, so side B should be larger than 4, which it is. So we've got angle C, side B. Now all that's left is side C. As far as doing this, I realize you do now have 2 options as far as angles that you could use. I'm going to say you are better off using the 40 degree over the 60 degree angle, because here you have a side length that was given to you as exact. If we can use an exact answer over a rounded value, that does give you a little better answer. So the final part's going to look a lot like what we just did over there. So the sine of 40 degrees over 4 will equal the sine of 80 degrees over C. Again, I am going to cross multiply. So C times the sine of 40 equals 4 times the sine of 80, and again divide. And when I do that, again, do make sure, close your parenthesis, and then divide by the sine of 40. And you end up with an answer of 6.1. And again, you can kind of look at the diagram as the angles get bigger, from 40 and 4, 60 and 5.4, 80 and 6.1. You can see as the angle gets bigger, the side across from it is also getting larger as well. So again, you can always kind of look at as a troubleshoot, do your answers overall fit. So the next set of notes, if you are printing things off, if we are given, going back to geometry, side angle side is a condition. Angle side angle, angle angle side, or side side side, there is only one possible triangle. To even come back and talk about what you were given here. 40, 60, and 4. That's angle, angle, side. So there is only one possible triangle I could sketch there. Now, if you are given what's called the ambiguous case, where you're given 2 sides and the non-included angle, side, side angle, you could end up with a situation where there may not be a triangle, there could be one triangle, or there is even the possibility of 2. And we'll talk about how you can determine whether there is 1 or 2 solutions. That even goes back to something you guys did in the last section in 5.5, where when you were finding that second answer for sine, you're basically dealing with, does that angle have a supplement that would fit within the triangle? And I'm going to add in a sine of 180 degrees minus x equals the sine of x. So, for example 2, now we're given side A, side B, angle A, and again, as to solve the triangle. So what I'm going to do, set up a sketch here. And again, it doesn't have to be perfect, but I am going to make that roughly 42 degrees. So now that means here is A, so here is 22. Side B is smaller than 22, so I'm going to make that my side B. Now, as far as setting this one up to solve, well, sine of 42 over 22. So that's sine of A over A equals the sine of B over 12. And again, I am going to cross multiply. And divide. So when I take 12 times sine 42, again, close your parenthesis, divided by 22. Now, unlike the last example, the decimal that you get is not b. That is the sine of b. So what we need to do to actually find b is much like what you did in section 5.5, is take the inverse. So when I take the inverse, and again, what I'm going to recommend, do not clear that out, just use that value. And you can see that the value of angle B is around 21.4 degrees. Now, in terms of whether you have one or two triangles, that comes from what's right here. If I take 180 minus the answer that I just found, I end up with 158.6 degrees. It is possible that B could equal 158.6 degrees. Now, as far as if I were to put that into my triangle, well, 42 plus 158 is 200.6. So that is not a possible second solution. So that's usually the most confusing issue in section 6.1 is there a second triangle or not? So angle B is just 21.4 only. Now, from there, all I've got to do is find angle C, which to do that, subtract both of those from 180. And when I do that, I get 116.6 degrees. And now all that's left is to find side C. So to do that, I'm going to use the law of sines once again. I'm going to use the two portions I was given for sure. So sine of 42 over 22 equals the sine of 116.6 over C. Here you don't have any choice other than to use a rounded value, but that's fine. At times that is going to happen. So from here, C times the sine of 42 degrees equals 22 times the sine of 116.6, and then divide. And when I do that, I end up with 29.4 as side C. So again, you can see that my answers fit. Again, my side across from the largest angle is the largest solution. So that's an example of an ambiguous case, side angle, where there is just one solution. Now if we look at example 3, side A is 15, B is 25, angle A is 85 degrees. Well, when I sketch this one, I am going to basically make that very close to a right angle. And B is 25, so I will put that side there. Now, as far as setting up our law of sines here, sine of 85 divided by 15 equals the sine of B over 25. Again, I am going to cross multiply and solve. Divide by 15. Now I am going to enter all that in and see what sine of B equals. So it's 1.66. So again, that's not angle B. We are going to take the inverse, which if you already see the issue, great. If not, when I take the inverse of that, my calculator tells me domain error. Well, the reason it's telling you that, going back to the unit circle, the sine of any angle cannot ever be more than 1. So if you get this answer that is an error, what this means, this is actually not information that can be a triangle. So again, that's one of the possibilities when you're given an ambiguous case side-side angle. All right, one final example. Solve the triangle where A is 12, C is 31, angle A is 20.5. Well, what I'm going to do here is certainly try to set up a sketch with a relatively small angle for A. Side A is 12, side C is 31. So from here now, what we can do is sine 20.5 over 12 equals sine C over 31 and cross multiply. And I will divide by 12, and that will give me the sine of C. .905. Well, from there, now we take our inverse. And it's around 64.8 degrees. Now, here is where, again, we do have to check for what is the additional answer. Now, the additional answer is the supplement of 64.8. So if I take 180 minus 64.8, I get 115.2. So here is an example where now I have to look at, would this fit possibly in a triangle with what we're given? And here it would. 20.5 and 115, that's only 135.7. So here is an example where we are going to have to find two sets of solutions. So to find my two other options for angle B, I am going to use both 115.2 and 64.8. So to start, one of them is 44.3 degrees. The other one (94.7). So you can see of the sketch, the 44.3 is the one that would fit better. Again, there's two ways you could have drawn this. One way would have been an acute angle B. The other way is a slightly obtuse angle B. Now, to finish, what I have to do is a law of sines involving both of these two angles. So, again, my two options for angle B are here. and here. So I know when you do have that ambiguous case with two answers, does have a little more to it. But we are now going to find side B. So again, use what you were given. Sine 20.5 over 12 equals the sine of 44.3 over B, and then cross multiply. So B times sine 20.5 equals 12 times sine 44.3, and then divide. So my first possible answer for side B is around 23.9. Now I'm going to do basically the exact same thing with 94.7 instead of 44.3. So sine of 20.5 over 12 equals sine 94.7 over B. And again, cross multiply. And divide. And when we do that, you end up $34.2. So again, as you guys work through the assignments on Pearson, they will tell you specifically how they want you to divide things out. So just kind of be aware there. Sometimes it will say nearest tenth, sometimes it will say nearest whole number. So just kind of be careful of that. All right, final topic in 6.1 is finding the area of an oblique triangle. Well, if you remember, area of a triangle back in geometry was just 1/2 base times height. Well, we are now going to use 1/2 times sides B, C times the sine of angle A, where it is the included angle, which in a sense is the formula you were using in geometry. You just were always using a right angle, which the sine of a 90-degree angle is 1. So now the other thing too that I will mention here, this is always involving side angle side. Now, you do not necessarily have to know all three of these, but basically what you can do is there are, in a sense, 3 versions of this. You do not necessarily have to write all of these out, but basically, if you're given sides A and C, you use B in between them. Sides A and B, use angle C in between those. So here you can see that, you know, they have not even given you any letters here. So if I wanted, I could fill in A, B, and C. So you can see that here is side C, side A, angle B that's included. So for this, the area of our triangle is 1/2 times 52 times 90 times the sine of 102 degrees. And again, just enter that in. And you end up with 2288.9 meters squared. So that does finish up 6.1. I know these notes went a little longer. There's a lot of calculations involved here. There is an assignment for this section in Pearson.